Hello everyone, my name is Arohi and welcome to my channel. So guys, in my today's video I'll perform vehicle and pedestrian detection using YOLOv8 algorithm and KITTI Dataset. But before moving to the practical implementation, let's understand why vehicle and pedestrian detection is important. So let's start with the autonomous driving. So in the development of autonomous vehicle, accurate detection of vehicles and pedestrian is important. Self-driving cars need to see other vehicles and people very well. They use this information to decide where to go, how fast to drive, and how to move safely. And if we talk about traffic management, monitoring and analyzing traffic flow rely on the detection of vehicles and pedestrians. This information is used for optimizing traffic signals, managing congestion, and planning infrastructure improvements. Let's talk about road safety now. Detecting vehicles and pedestrians is important for preventing accidents and ensuring road safety. By identifying these objects in real time, advanced driving assistance systems can provide timely warnings to the driver, and this will help in avoid collisions and ultimately reduce the number of traffic accidents. Okay, now let's see the dataset. Now type KITTI Dataset and then open this first link. So this is the KITTI Dataset website, and KITTI Dataset is a popular dataset used for computer vision tasks, particularly in the context of autonomous driving. And guys, since its release, KITTI has become one of the most cited and used dataset in autonomous driving and computer vision research. And this dataset is collected from a variety of urban, suburban, and then highway environments, offering a broad spectrum of real world scenarios. And this diversity helps in training models that are capable of operating under different settings and conditions, which make them more versatile and reliable. Okay. And this KITTI dataset include detailed annotation for vehicles, pedestrians, cyclists, and some other objects in 3D and 2D format. We can perform 2D object detection, 3D object detection, we can perform tracking, we can perform lots of this computer vision task using this dataset. And if you want to see the dataset, so first, before showing you the dataset like 2D and the 3D dataset, let's click on this setup. If you'll click on this setup, you will see the entire setup of the car on which they have collected this data. And you can see over here the sensor setup, all the sensors and their details have been mentioned over here, and what all things they have used to set up this car to collect the data. All that sensor setup detail you can see on this page. Now just see this object. Under this object you can see 2D object, 3D object, and then the bird's eye view. What it means is that you can work with it has 2D data, object annotations, 3D object data annotations, and the bird eye view. Okay, now for our today's problem, we are performing object detection. For that we will go to this 2D object, and you will be redirected to this page. Okay, and on this page you can see this first link: download left color images of object dataset, which the size is 12 GB. We will download this file, and how you can download it, just click on it and this download will start, and you will get a zip folder inside your downloads folder. And to download the training labels, you will click on this link: download training labels of object dataset, and the size is 5 MB. When you will click on this, you will get a zip file inside your downloads folder. Now let me open the downloads folder and show you where this file is. Okay, so let's go to the downloads, and here you can see this one, okay, these are the images, and I have unzipped it, and this is the folder, and this is the other folder, the training labels, and after unzipping it, this is the file. Now let's open these folders one by one and see what all things are there. So first I'm opening this training folder, images folder, data object image folder. Inside that you will get two folders, training and testing. And let's open training folder. Inside that you have one another folder, and inside that here you can see all the images. So we have 7481 images, training images. Let's open one image and see. So these kind of images you have, okay, training images. Now let's go back and go to this testing. Inside testing we have test images, okay, so we have 7518 test images. So guys, this is how these are the images, okay. Now let's see their corresponding annotation files, text files, okay. So for that we are clicking on this label folder, and inside that, see guys, here you can see that we only have training folder. Under images we were having two folders, training and testing, but under label we are only getting the labels of training dataset. Now let's open it, and you can see we have 7481 annotations which are in text format. So we are not having the annotations for our test files, and we have this annotations for this training data only. Now let's open one of the annotation file and let's try to understand what kind of values we have in it. Let's open this annotation file. So this is the first annotation file, and this is a class name, and then we have these different values over here. Now let's understand what these values are. So guys, each line in the annotation file describes one object in a scene. So in this text file we have only one line. That means there is only one object in this image. So suppose if you have an image which have three different objects, then you will have three different lines, and one line will give you the information related to one object. So now let's understand what all components are there in this annotation file. For the so the first one is this one is object type, and in this case we have pedestrian, and this indicate the type of object annotated. And so guys, in this KITTI dataset the different objects are car, pedestrian, van, cyclist, truck, and then there is a miscellaneous class also, tram, person sitting, and don't cares, okay. So these are the different 8 classes KITTI dataset is trained on, and this don't care class simply refers to a region of an image that contains objects which are not of interest for our specific task, okay. So after that we have this 0.00. Now what it is? So this is truncation basically. So what it measures, the value is 0.00, and this truncation measures how much of the object is visible. The truncation is typically between 0 means fully visible, and 1 means not visible. So in our case it's 0, that means the object is fully visible. And then we have the next value, which is this 0. Occlusion. It indicates the level of occlusion of the object. So let's suppose over here we are having a 0 value, so that means the object is fully visible. And if over here we have 1, that means the object is partially occluded. And if we have 2 over here as a value, which means that the object is largely occluded, and 3 means unknown, okay. So here you can have 0, 1, 2 or 3 value, and I've told you what all values what every single value means, okay. And then we have this minus 0.20. so this is the observation angle, 0.20. so the observation angle of the object, so this minus 0.20 is the observation angle of the object relative to the camera view, okay. And then we have these 4 values as our bounding boxes. So for object detection we need a bounding box. Bounding box simply means a rectangular box around the object. So for that we need 4 coordinates. So this is the first coordinate, second, third and fourth. These are the 4 values. So these 4 values define the pixel coordinates of the bounding box surrounded the object in the image. So it is given by 4 values. First one is xmin, and then we have ymin, then we have xmax, and the fourth one is ymax, okay. So these are the 4 values. After that we have these 3 values, 1.89, 0. This and this. This is basically a 3D dimension of the object, okay. 3D dimension means height, width and the length. So height over here is 1.89 meters, width over here is 0.48 meters, and length over here is 1.20 meters. Okay, so then we have this. After that we have location, these values over here, these three values, first value, second, and this third value. This tells the 3D location of the object in the camera coordinates, so which is right, down, and forward, 3. Okay, after that, and it is also in meters, guys. After that we have this last value, which is 0.01. This 0.01 tells the rotation of the object around the y-axis, which is up in radians, and that's it, guys. So this is in this KITTI dataset. Every annotation file will have these kinds of detail. You will have object type, then occlusion type, and then the movement in the 3D dimension, 2D dimension, object bounding box, whether the object is occluded or not. So all these details you will get for each object. Okay, but now the next thing is we have downloaded the data, right? So now once you download the data, our next task is to convert these annotations into the format which YOLO model accepts, right? So for our YOLO model, what things we need? We only need the class label and the bounding box. So we need this and these 4 values. Okay, so apart from these things, bounding box coordinates and the class name, we don't need any other detail. So you have to write a script which will help you to have the annotations in the YOLO format. Now let me show you. I have converted these annotations into the YOLO format. Now let me show you that. Okay, so guys, this is my folder where I have the dataset which is in YOLOv8 format, and my training code, everything else is in this folder. Okay, so let's open this dataset folder. Inside this dataset folder, I have created 3 folders: train, test, and val. Inside train, I have 2 folders: images and labels. And inside this images folder, I have pasted the training images which we have from downloads. Okay, from here we have the training images. So how many training images we have? 7481 images. So what I have done, I have pasted 7000 images in the train folder and 480 images in the validation folder. So guys, what I've done, I have divided my training images which we downloaded from the KITTI dataset. I've split that dataset into 2 parts, train and val, and 480 images I pasted in validation folder, and remaining 7000 images I have pasted in the training folder. Okay, and the same way, their corresponding under the labels, I have pasted the labels. Okay, and 7000 labels we have in for training images, and 480 labels we have for this validation images. Now let me open the labels file and show you what kind of files we have now. So this is the first file. Here you can see this is the class ID, and these are the 4 bounding box coordinates. Now we have our annotation files in the text format, in the format which our YOLO model accepts. Now we can train our model. For training a model, we need to install the Ultralytics package. So this is how you install it: pip install Ultralytics. And after that, I am just showing you the version of Ultralytics which I am using, and my Torch and CUDA version is this. I'm using CUDA 11.8, and this is the GPU on which I'm working. Okay, now let's import the Ultralytics. After that, I don't want to train my model from scratch. What I'm doing is I am just loading the pre-trained YOLOv8 model, and then I am fine-tuning that model on my custom dataset. So how we do that? We load the pre-trained model, and in this line model.train, we have a data.yaml file. Now let's open this data.yaml file and see what is there. So this is my data.yml file. Here you can see the file. So here I have provided the path of my training images, and here I have provided the path of my validation images. We have total 9 classes, and these are the name of those 9 classes. Okay, so this is my data.yml file, and using this file, our algorithm, this YOLOv8 algorithm, will be trained on KITTI Dataset. So I have trained the model for 200 epochs, and the batch size is this, and the image size is this. So after the training, you will get a runs folder. So inside the detect folder, you will see a train folder. Open it, and inside the weights, you can see the last and the best weight. So this is the trained model. Now we will use this model to make predictions on unseen data. So, and here let's open the confusion matrix. You can see the confusion matrix. Okay, and if you want to see the result here, so these are the map values when the threshold value is 50, and map values when the threshold value is between 50 to 95. So now our model is trained. Let's test our model. So for testing our model, so guys, this is how you train the model. And let's suppose if you want to, due to any reason, your training stopped in between, then you can resume the training using this code. So what we did over here, we just, you just need to provide the path of the last weight, and then model, and then model.train and resume true. This is how you can resume the training. Okay, now let's see how to perform predictions on unseen data. So for that, you need to provide the path of your trained model. So we have our trained model, this inside this folder, and then if you want to test on images, just give the path of the image. Save true will save your result in runs folder. And then if you want to test on video, then this is my video on which I want to perform the testing, and save true. Now let me show you the output video. Okay, let's go here, open this one. So this is the video one. Let's open it. So here you can see it is, let me stop it. So here you can see we are detecting pedestrian, car class. See, cyclist is getting detected. Okay, now let's see prediction on one more video. So guys, this is how you perform a vehicle and pedestrian detection using YOLOv8 and KITTI Dataset. I hope this video is helpful. And guys, if you like my video, please like, share and subscribe my channel. Thank you for watching.